Go up for one.
Yes, Aristotle 3.1, fundamental rule of counting. I'm going to teach you how to count. 1, 2, 3. So, the fundamental rule of counting states if an experiment is done in m ways, and then you have another one that is done in n ways, they will happen together in m times n ways. You may ask me, well, what do we have to know about counting? If you look at the definition of probability, we always want to know the number of ways in which an event would happen divided by the total number of events. Sure, I can sit and write down all possible outcomes in the sample space, but that's a waste of time. Some cases you just cannot do it. And that's where the fundamental rule of counting and other techniques come into play. So suppose a 6-sided die and a 4-sided die are thrown simultaneously. How many possible outcomes would we have in the sample space?
24.
24. How did we get 24? You just multiply 6 and 4, right? So m number of ways for the 6-sided die. When I mean m number of ways, I mean 6 possible outcomes. And n number of ways, n is equal to 4. So in total, if you throw a 6-sided die and a 4-sided die simultaneously, you would have 24 possible outcomes. Sure, we can sit and write all this out. I'll do it this one time. Just to demonstrate how painful things can get. So 1, 1. It's up to you. Right, so those are the 24 possible outcomes. This is one way of doing it. Another way is to draw a tree. You might have learned that in the past. Even though in this case it is easy, what if you had 50-something possible outcomes for one experiment, 40-something outcomes for another experiment? In total, you have 2,000 possible ways. Do you really want to sit and write all of them?
No.
No, there has to be an easy approach. And that's what we will do, Steve. Okay, so a bunch of problems, 11 through 16. Or
11.
Or no, what? We're going to do all of them, 11 through 16.
Perfect.
Because it's matching probabilities. We'll start with 11. So you have a random number generator. You've got to select a number between 1 or from 1 to 100. What is the probability that you choose 153?
Zero.
0. Okay, good. What about the next one? 50%, that would be 0.5 F. What about number 13?
Zero. I don't, wait.
Think about fundamental rule of counting. How many experiments do we have?
200.
200. What?
You would take, wouldn't you take 2 and divide it by, or you would take like 1 divided by 9 and 1 divided by 19 and add like multiply the 2 together and.
Close, but it's not 1 divided by 9, it's actually 10.
Oh,
Right.
right.
0 through 9, you have 10 possible ways. So the first number can be selected in 10 possible ways. The second number can be selected in 20 possible ways. In total, you have 200 possible ways. And what is the probability of selecting 3 both times? It can only happen once, so 1 out of 200, that's half the probability big. What about number 14?
Three doors, equal, no way, but 0.25.
How much?
0.25. It's 1 out of 4.
0.25. So there are 4 doors and one of the door has money, doubling the money. The other 3, no money. What is the probability she selects the door that doubles the money? 1 out of 4. What about number 15?
95 out of 100.
95 out of 100. What rule did we use?
Complement.
The complementary rule. Okay. We've got all the answers sorted out. That leaves us with 1. Yes.
Well, for 13, how did you get 1 out of 200 if they're trying to get 3 out of both samples?
So you want the number 33. Think about it this way. 3. So only one way you can get 3 out of 200 possible ways.
Oh, okay.
So we've got all the answers except number 16, and 16 has to be 0.375. Do you agree?
Yeah.
I'll give you a few minutes. Let's see if we can get it right.
0.375%.
Yeah, you got to tell me how. So you toss the coin 4 times. What is the probability of tossing tails exactly half of the time?
You do one half times. No, 1 half power of 4.
Each time you get 2. So the first time you have 2 possibilities, second time 2 possibilities, 2, 2. In total, you have 16 ways or 16 outcomes. And we want to know how we could get tails exactly half of the time. So who had 3 over 8 or 6 over 16? How'd you get it?
Well, I put 4 coins and saw that in exactly 6 different ways you can get half the time tails.
He did
Just
actually
logic.
drawing it out.
So Heads, heads, tails, tails. So the only things that would matter in this case, I have 2 coins would be heads, tails, and tails, heads, yes, and tails, heads.
They want 4 times.
That's for coins 1 and 2. Do you agree?
Yeah.
So coin 1 here, coin 2 there. If you do coins 3 and 4, you could do the same thing. That would be heads, tails, tails, heads, and tails, head. Right? Now, in total, how many possibilities would we have?
Oh, you're not accounting for.
I forgot 1 coin.
Yeah.
What did you say, Hunter?
Don't you also have to account for possibly 1 and 3, 2 and 4?
Yes.
Yeah, so you just have to keep.
There are 2 more, so we have coins 1, 2. Here, coins 2 and 3, coins 3 and 4, coins 1 and 4. So the process would repeat itself a few more times. So you'd have heads, tails.
Understand that. There are.
So in total, you have 16 possible ways, right? 4, 4, 4, 4. You can write them all out, but if you use the fundamental rule of counting, you already know there are 16 possible ways. In how many of those ways could we get 2 tails? If you count, you would have 6.
Yeah,
Right? If you combine everything together, you will get 6. Which will give you 3 out of 8 or 0.375. This is one way of doing it. Another way of doing it is drawing a tree. So you have heads, tails, heads, tails, heads, tails. Right? You've got to continue that process for all possibilities, and you would get 16. And then you can count the number of outcomes that would result in 2 tails. So here I would have heads, tails, heads, tails, heads, tails, heads, tails. I'll write it in a different color so that you don't get confused. Right, so we just built a plan here. So you can list out all the possibilities just by looking at each of the letters. This is the tree approach and tree diagram. So one of the outcomes would be H, 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 H. The next one would be H, 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 T, and so forth. I don't want to lose my breath. So if you look at the branches, how many of them would result in 2 tails? There is 1, 2, 3, yes? And it doesn't matter what you have here, you will get 1, 2, 3, so in total 6. Does that make sense? So either you could draw a table or a tree, most people prefer this, but even that will get really hard if you try to do it for multiple outcomes. Does that make sense? So this is a problem on fundamental rule of counting. Each of them is an experiment, getting appetizers, entrees, and desserts. So the first one happens in 6 ways. The second is entrees, so 12 ways, and the last one, 8. If you multiply them all together, you will get 576 possible ways. Does that make sense? So our objective is to come up with the total number of possible ways and then number of possible ways for a specific event without even writing them down. So that's the goal. And that's why we are doing counting.
That's a long.
So we have 6 characters in an access code, and each character could be a letter or number. There are 26 letters in the English alphabet, FYI. So 26 letters and numbers from 0 through 9. How many numbers do we have? 10. So in total, how many characters do we have?
36.
36. So I recommend, writing something like this always helps. Cool, right? The first character must be a 0, right? In how many ways could that happen?
First character can't be.
No,
a
yeah.
zero.
Oh, it can't be a 0?
Yeah.
Okay,
Yeah.
if it can't be a 0, how many possibilities do we have? 35. What about the next one?
36.
Next one?
36.
Next one?
36.
Next one?
5.
No, 31.
31.
5. It has to be an odd number.
Or.
The last 2 characters must be odd numbers.
Must be odd. Last 2 characters must be.
Must be odd numbers. So they have to be odd and they have to be numbers. So that would be 1, 3, 5, 7, and 9. So if you multiply all that, what do you get?
1,134,000. Yes.
All right.
Exactly. Oh, makes sense. That's 25.
All right, yeah, I got a study.
I mean, if you didn't know the fundamental rule of counting, do you really want to sit there and write all these possibilities?
Hunter would.
That's extra credit. What about the probability? Probability of selecting the correct access code in the first try. In other words, in 1 try.
1 million. 1 out of 1.
1 out of that.
Yeah, not happening.
Wait, how'd you get that?
How'd you get that number?
They told me
That's not the right number.
Who knew that number?
So multiply all of those.
That's not bad.
That's not correct.
Hey.
Yeah, it's way better than that.
How much is it?
Oh, it's 40 million.
Yeah,
Exactly 40 million?
no,
40,824,000.
40, 8, 2, 4, 0, 0, 0.
I just listened to him. I believe that.
Wait.
There's your decision.
40,824,000.
Wow, 40,824,000.
There you go.
Yes, I
Okay,
don't know how to pronounce numbers.
it's okay. I don't like it. So,
About a couple million. It's okay.
I can just say them whenever together.
and that is a very small probability, and what do we get? It's like 2.5 times 10 raised to negative 8.
Yeah.
Do we have your calculator?
I'm not.
1 over 40 1,824,000.
Well, it says 0.24
Yeah,
for
Yeah.
Yeah, okay, so 2.5 times 10 raised to -9.
why not?
I moved the decimal. Yes,
What you get?
10, 0 for 9.
Okay, and then, I just say that's the same thing in the.
Yeah, it's a problem, so letter or a number and 0. Good, are we clear? Any questions? No? I was actually right, because that's the number I had. Right. Okay.
Doesn't matter. Sure.
Sunny. Cloudy.
So a day can be sunny, rainy, or cloudy. What is the probability that the next 3 days are sunny? So how many possibilities do we have for day 1?
3.
3. How many do we have for day 2?
3.
How many do we have for day 3?
3.
So in total, we have 27 possibilities. And we want to know what is the probability that the next 3 days are going to be sunny. It's going to be 1 out of those 27 possibilities, right? Another way of looking at it, what is the probability that the first day would be sunny? It's 1/3, right? 1 out of 3 possibilities. Second day, it is 1/3. Third, it's 1/3, so it'll be 1/27, right? So the probability is 1/27. So all days are sunny. There is only one way in which that could happen. So the probability is 1 out of 27. One way of doing it. This is the other way of doing it, and this is a good lead into the next topic, which is multiplication.